Formula and variations. A formula is a mathematical statement that gives the relationship between given quantities. Variables are the quantities represented by the formula. Example of formulas are shown below. Changing the subject of the formula. A subject is the variable written in terms of others. In the above three cases, C, N, and X are the subject of the formula. Rearrangement of the formula to make another variable the subject is called the changing of subject of the formula. For example, make h the subject of the formula V is equal to pi r squared h. In that solution, we divide both sides by pi r squared and we get h is equal to V over pi r squared. Make C the subject of ax squared is equal to bx plus c. If we subtract bx from both sides and then factorize, we'll end up with c is equal to x into ax minus b. Make a the subject of the formula. N is equal to xt squared over a minus t squared. If we multiply both sides by a minus t squared and then factorize, we will end up with the answer as n into a minus t squared is equal to xt squared. Na minus nt squared is xt squared. If we add nt squared to both sides, we have Na is equal to xt squared plus nt squared, and then we divide both sides by n. Variations. When two variables say a and b are related such that a is equal to kb, where k is a constant, then a is proportional to b, or a varies as b. Thus, a varies as b is written as a alpha b, and it's similar to a is equal to kb. K is called the constant of proportionality or coefficient of variation. Direct variation. Consider the table below. It shows the cost of raising a given number of children. From the table, the ratio of children to cost is constant. That is 1 to 10 equals to 2 to 20 equals to 3 to 30. As the number of children increase, the cost increase as well. We say that cost varies directly as the number of children. If the number of children is n and the cost c, then c over n is 10 over 1, which is equal to 20 over 2, equals to 30 over 3, which is equal to 10. Hence, 10 is the constant of proportionality. Thus, we can have c is equal to 10n. This is the expression of that relationship. This equation is a linear one. It can be represented graphically as shown below. In summary, if x varies directly as y, the relationship is written as x alpha y, which is also similar to x is equal to ky. Therefore, x over y is equal to k, where k is the constant of proportionality. The gradient of such a linear graph is equal to k. For example, considering the table below, from the above values, determine k and determine the relationship between x and y, hence plot this relationship. Y over x is equal to k, which is equal to 4 over 1, equal to 8 over 2, and is equal to 4. The relationship is given by y is equal to 4x. Plotting that, we end up with the graph shown below. Note that for a linear relationship, 2 points are sufficient to plot the graph. Inverse variation. If two variables are such that when one increases, the other decreases at a constant rate, then the two are inversely proportional. Such relationship is represented as A alpha 1 over B, or A alpha B raised to power negative 1. Therefore, A is equal to K over B, where K is the constant of proportionality. Thus, A times B is equal to K. A good example is speed and time. If the speed of a car increases, the car takes less time to complete a journey. That is, suppose the distance to be covered is 200 kilometers. We can represent this information as shown below. Let's find the relationship. If speed is s and time t, s is proportional to 1 over t. Therefore, s is equal to k over t, which means s times t is k. Taking any two pairs, 50 is equal to k over 4, and therefore k is equal to 100. Hence, the relationship is s is equal to 100 over t. When plotted, we obtain a curve as shown below. The curve approaches both axes but never touches them. This behavior is called asymptotic. To obtain a linear graph, we plot the inverse of time instead. That is, the graph of s versus 1 over t instead of s versus t. We shall have 1 over 4 equal to 0.25, half equal to 0.5, and so forth. When we plot these values, we obtain a linear graph as shown below. Joint variation. This occurs when one variable varies as a product of two or more other variables. For example, V is equal to pi r squared h. Volume V varies directly as r squared and as h. Pi is a constant. For example, if a variable A varies jointly as B and C, and that when A is equal to 20, B is equal to 2 and C equals to 4, find the constant of proportionality. Also find A when B is equal to 4 and C is equal to 3. In our solution, A alpha B C means A is equal to K B C, equation 1. K is equal to A over B C, which is equal to 20 over 2 times 4, which is 2.5. Using equation 1, when B is 4 and C is 3, A is equal to 2.5 times 4 times 3, which is equal to 30. Partial variation. The Kenya Power and Lighting Company charges a standing fee of Kenya shillings 400 per month. Also charges Kenya shillings 50 per megawatt of power consumed. If a customer consumed 200 megawatts of power in a certain month, he would pay 400 shillings plus 50 times 200, which is equal to 10,400. How much would another customer pay after consuming X megawatts? If C represents cost, then C is equal to 50x plus 400. Here we say that cost C is partly constant and partly varies as X. Similarly, A is equal to AX plus B over X means that A partly varies as X and partly varies inversely as X. A is equal to AX plus BY means A varies partly as X and partly varies as Y. A and B are constants of proportionality. An example, a quantity y varies partly as x squared and partly as x. When x is equal to 2, y is equal to 14. and when x is equal to 3, y is equal to 24. Find the relationship between x and y. In our solution, y is equal to ax squared plus bx, where a and b are constants. When x is equal to 2, y is equal to 14, and therefore we have 4a plus 2b is equal to 14. When x is equal to 3, y is 24. Therefore 9a plus 3b is 24. We solve the simultaneous equation and we shall end up with a is minus 1 and b is 5. Therefore the relationship is y is equal to minus x squared plus 5, which can also be written as 5x minus x squared. That brings us to the end of formula and variation.
What are you looking for in a college? Many students discover that when they attend a large university, they become just another face in the crowd. Well, not at SAGU. Here, there is one professor to every 19 students. That means instead of being a face in a crowd, you know and interact with your professors personally. You'll be joining more than 2,000 students from 46 states and 35 countries for a college experience like no other. Because at the center of everything we value are our commitments to Bible-based education and academic excellence. Here at SAGU, we offer more than 60 degrees, a full selection of sports, clubs, and organizations, and international travel to make your life as a SAGU Lion a memorable and empowering experience. Our average annual cost is half of the national average for other private schools, and we award $28 million annually in financial aid, with 92% of students receiving some form of financial assistance. Now, you might be wondering, where exactly is SAGU? Well, you know where Dallas, Texas is, right? SAGU is in Waxahachie, just south of Dallas and Fort Worth, close enough to benefit from the restaurants, pro sports activities, churches, and jobs of a booming metroplex. So, if you haven't given SAGU a close look, perhaps it's time.